কি ব্যাপার, আমি করতে পারছি না তো।
আচ্ছা, কি বলে, চট্টরাজ বলছি, স্পিকার সাথে কথা হয়েছে, স্পিকার জয়েন করছে এখনই।
বলো।
আর ওদিকে স্পিকারকে কোর্স করে দিস।
করে দিয়েছি, দেখে নাও একবার।
হ্যাঁ, স্পিকার জয়েন করছে। আচ্ছা, শ্রেয়াকে একটা জিনিস দেখিয়ে দিস। শ্রেয়া, ক্যান ইউ হিয়ার মি?
Yes, sir. হ্যাঁ স্যার,
দেখো, এই যে নিচের দিকে শেয়ার স্ক্রিনের পাশে একটা রেকর্ড বলে অপশন আছে, দেখছো?
হ্যাঁ স্যার।
ওই রেকর্ডের উপর ক্লিক করলে দেখবে অপশন দেবে তোমাকে, ঠিক আছে? ওখানে রেকর্ডের উপর অপশন দিলে তুমি ওখানে দেখবে অন লোকাল কম্পিউটার, রেকর্ড অন দিস লোকাল কম্পিউটার বলে একটা অপশনটা পাবে। ওকে, রেকর্ডটা এখন রাখো, পজ রাখো। রেকর্ডটা যখন স্পিকার শুরু হবে, যখন প্রোগ্রাম শুরু হবে তখন করো, ঠিক আছে? রেকর্ডে গিয়ে যে রেকর্ড অন দিস লোকাল কম্পিউটারটা কিন্তু, হ্যাঁ, ওই অপশনটা সিলেক্ট করবে, ঠিক আছে শ্রেয়া? ওকে, কি বলে চট্টরাজ?
বলো বলো বলো।
হ্যাঁ, বলছি প্রোগ্রামটা যখন হবে, ওই মানে কারা কারা জয়েন করছে ওটা একটু খেয়াল রাখিস, ঠিক আছে?
কারা কারা জয়েন করছে?
এখন যে প্রোগ্রামটা আছে আমাদের, সবাই 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 না জয়েন করছে ইন দ্য সেন্স, মানে ওই আমার তো করতে হবে, এই অ্যাডমিট করতে হয় তো।
সন্দীপন দা মিউট আছো।
Oh, sorry. So sorry for the interruption. Today we are about to start our today's webinar, and our speaker is about to join. So please stay with us as we are going to start shortly.
I ask all the participants, please mute yourself.
Um, Hello, participants. I just have had a talk with our today's speaker, as he has informed that there is a technical error that he is currently facing. So he is joining shortly within next 3 to 4 minutes. So please stay with us as we will be starting this program ASAP, probably within next 2-3 minutes. Sorry for this inconvenience. Please stay with us. Don't leave. Participants, we are really sorry that the program is under delay. So, as our speaker is joining shortly, as he is facing some technical issues to join through his system. So please stay with us. He has confirmed that he will be joining within next 2 minutes.
ऐसे बहुत सारे विषय आपको मिलेंगे
सब बंद हुआ
Hello, everyone. Good evening. Our today's program is going to start as our today's speaker has
Sure.
joined. Dr. Roy, can you hear me?
Yes, I think I'm also audible, right?
Yes, you are pretty much audible. And sir, can you please check that whether you have been made the co-host of this session or not, please?
Yes, I think I have been made as a no.
I request.
Yes,
Just one
yes,
second.
right now. Okay.
Yes, you have been made the co-host.
Yes,
Sir.
right now. Okay.
Okay.
Yes.
So
yes.
today,
Okay.
so sir, with your permission, we are going to start this session.
Yes, you can.
Okay. And also we have our honorable principal ma'am with us to bless this session. So let me just start this program with all of your permission. So today, Department of Civil Engineering and Eco Club of Greater Kolkata College of Engineering and Management is going to arrange a webinar on arsenic contamination of groundwater in GMB plain and mitigation technologies. And to enlighten this session, we have Dr. Abhishek Roy, Assistant Professor, Department of Civil Engineering of Jadavpur University. So before we start, I would like to welcome Dr. Mohadas, Principal, GKCM, to say a few words about this topic of this webinar. Ma'am, the session is over to you.
Thank you, Shantipan. Am I audible?
Yes, ma'am.
Okay. A very good afternoon to all distinguished speaker and all my beloved students. Today we have gathered here for the webinar Arsenic Contamination of Groundwater in GMB Plan and Mitigation Technologies. I appreciate the team for organizing this webinar because arsenic contamination is a burning issue, though we are not much aware about that. I don't know how many of us know the level or how many of us aware about the arsenic contamination, and you know where you are staying, where you are spending time in your institute. This is a contaminated area. As per Indian standard, the level of arsenic which is allowable in our drinking water, that is 0.0 milligram per liter, that is per ppm, and exposure to higher or lower amount, that will cause different type of problem, maybe fatter. There may be liver, kidney damage, maybe skin problem, maybe shortage of red and white blood cell. There are so many problems. Now the question is, how arsenic is getting contaminated in the water? It may be anthropogenic, it may be natural. One point is when pH of soil is high or water is high, then arsenic may be released. You know that in soil, in rock, there arsenic are bound in different form. So from there may be dissolution of arsenic in groundwater. Sometimes if there is organic carbon in higher amount in groundwater, then bacterial activity with different compound may release arsenic in groundwater. And another problem, that is the most important problem, the arsenic trapped in sulfide minerals can be released when the minerals are exposed to oxygen, and when they are getting exposure of oxygen, when the water level drops and minerals are exposed to air. And that is the problem of urban area, because day by day using of submersible pump and due to high rise, there is drop in water level. Now, to understand the severity of the arsenic crisis in West Bengal, a detailed 3-year study was undertaken in Murshidabad. One of the 9 arsenic affected areas in West Bengal, they have found. The district covers an area of more than or near about 6,000 square kilometer with a population of more than 5.5 million. In India, there is West Bengal, Jharkhand, Bihar, Uttar Pradesh, Assam, Manipur, and Chhattisgarh who are affected by arsenic contamination of groundwater. So it is easily understandable that what a burning issue this is. So I am not the right person. We have distinguished speaker, Dr. Abhishek Roy from Jadavpur University, and I heartily welcome sir in our virtual platform. I'm confident the session will be enriched one, and our students, our all the members from GKCM will be enriched by his talk. Thanking you, sir, for sparing your valuable moment with us, and hope that you will be physically in our institute in near future when this pandemic situation will be over. Thanking you, thanking all. Over to Shandip.
Thank you, ma'am. Thank you for your inspiring words and insightful thought on this particular topic of today's webinar. So we are about to start. So before I hand over this session to Dr. Roy, let me just a brief introduction about Dr. Roy. Dr. Abhishek Roy has completed his BTech in Civil Engineering and Master of Civil Engineering in Environmental Engineering from Jadavpur University. He has also completed his PhD from Jadavpur University as well. And he has worked in civil organizations so far, and recently he has joined Jadavpur University, and currently he is appointed as the assistant professor from the Department of Civil Engineering with specialization in environmental engineering. He has several publications in both national and international forum. So, may I now hand over this session to you, sir?
Thank you, HOD sir of Civil Engineering Department of GKCEM, and also thanks to Principal Madam. And I also sincerely want to thanks the organizer, especially Department of Civil Engineering and the Eco Club of GKCEM. So thank you for all for
Pleasure is all
organizing
our,
this
sir.
sort of.
Pleasure is all our.
Okay, so
So, sir,
thank you all
please start.
for
Continue,
organizing.
sir.
Yes, yes. So thank you all for organizing this sort of session. So I will go into the presentation. However, the discussion will not be limited to only just me presenting the slides, right? So any point of time, the students, whenever you feel you need to understand that slide or that portion in a better way, you can raise your hand or you can ask me directly, right? So this will be more or less a interactive session. I will try in a way, I will try to present so that it will be an interactive session rather than a very complicated academic presentation. Okay. So without saying further, I'm directly going to my presentation. Is it visible to everyone?
Yes, perfectly all right, sir. Perfectly all right.
Okay. Okay. So today we gather here to mainly discuss the arsenic contamination in groundwater of the GMB plain and the mitigation technology. So you know that there are certain thing which you can't you can't avoid. One such sort of situation is the arsenic contaminated groundwater for this GMB plain. We consider the Ganga, Meghna, and Brahmaputra, the entire region, right? So majorly contaminated area is this plain, and the majorly affected people are living on this plain. So, like if you consider the people of West Bengal and the people of Bangladesh are the worst sufferer of this problem. Okay. Now, if I go in introducing arsenic, then before that I have to discuss about the water. As we know that water is very much needed or indispensable for the endurance of the human being. That means for any human being to live, we need the access of drinking water. We need the access of safe drinking water. Why I'm saying safe drinking water? Because you know there is so much of water. We know when we have studied in our very basic classes also, we know there is so much of water, but there is water everywhere, but very less to drink, because the safe drinking water sources is very limited. You know, right now almost throughout the world, peoples are mainly depending on the surface water sources. Although we know that surface water sources is heavily contaminated by the mainly by the suspended particles, then you are having the bacteriological load, which is relatively less in the groundwater. Still we are depending on that. Why? Because groundwater so many times is contaminated with some metals and some toxic harmful elements like arsenic, fluoride, all these things. So if you consider arsenic, only arsenic contamination, if you consider due to the drinking water sources, or if you consider the pathway as the drinking water, then 144 million people around the world is basically affected by arsenic contamination. In 1993, World Health Organization have lowered the limit of arsenic in drinking water from 50 microgram per liter to 10 microgram per liter. So earlier it is 50 microgram per liter, but seeing its effect on the people, they have lowered the limit to 10 microgram per liter. But when they have just lowered down this limit, what happens? There is so many country and so many water bodies or so many place where we are taking the water from the groundwater is coming under the scanner. That means so many place or water in so many place become toxic become toxic, because before that we are not considering that. Suppose a a water source having arsenic of 30 microgram per liter. Before 1993 we are not considering that as a toxic one, but after 1993 we are considering that as a toxic one, because we have seen throughout the scientific literatures that even at 10 microgram per liter also the toxicity of arsenic is much higher than the other waterborne toxic elements. Now, when they have lowered this limit, there is an urgency to develop certain kind of treatment units which can treat the arsenic containing groundwater to a level that we will get the product water which will have a arsenic concentration less than 10 microgram per liter. So
Sir, you are not audible, sir.
no, in my, am I audible right now?
Yes, yes, audible, sir.
Okay, so just 1 or 2 seconds earlier, I got a message that host has been muted you. That's why. Okay.
No, 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 no.
So I have not done anything. Okay. Okay.
Please
So
continue, sir.
yeah. So due to this stringent drinking water quality, right now there are very few technologies available which can treat this drinking water, where we can get the product water of arsenic concentration less than 10 microgram per liter, because you know that 10 microgram per liter is allowable. Above than that is basically toxic for us. Okay. Now, whenever, as I have told, that there is so many development or so many urgency, so much of urgency to develop new technologies. Now, any technology will be sustainable and economically viable only in the case when the problem is spread over the world. Also, the contamination scenario is different. That means the peoples are getting affected due to this problem, and also the technology is low cost, and the byproduct which is generated from the technology also should be economically and environmentally a stable solution. That means the waste which will be generated from a treatment unit, it should not be another source of arsenic contamination, right? So these things should be keep in mind while developing a technology. Now, before going into the details of the technology or how to remove that, because as an environmental engineer or the students of civil engineering discipline, our target always will be to solve the problem of the civil society, right? Because our main target is to solve the problem for the civil society, and drinking water is one of such problems. So obviously our target will be more in the application of the engineering to solve the problem. Okay, so we will discuss that part majorly, but before going into that part, I am just going through few slides where I will discuss about the natural presence of arsenic, toxicity, and also the health effects related to it. So as you know, if you look at the natural sources of arsenic, these are the few minerals which will obviously have arsenic in it. Now these sources are earth crust sedimentary rocks, or can be weathering of volcanic rocks. These all can contain arsenic. Now, how arsenic is coming as an ion, or arsenic is coming into the water, that can happen if we go by the mechanism of the arsenic contamination. That mainly happen because of reductive dissolution. So it will reduce to some form and it will dissolute and ultimately comes in the water, comes in the water. Or it can be alkali desorption. Whenever at high pH, if you are having, then direct desorption of stable arsenic can be there. Also the sulfides oxidation, that also can be there. Okay, I'm not going very much details in this mechanism of arsenic contamination. From this, our takeaway point will be that arsenic containing rocks is there. Whenever water is passing through that, due to some changes in the environmental condition, arsenic will comes into the water, right? there are some anthropogenic sources, or you can say anthropogenic aggravated natural sources is also there, but major source of arsenic contamination in groundwater is natural. Okay, the presence is natural, however due to some human activity that position or that situation is getting aggravated, that is for sure, but the contamination's original nature is natural. Okay, then some other anthropogenic sources also can be there, like some fossil fuels contains also arsenic, and if you burn them, that will also comes in the air atmosphere, not directly in the water atmosphere, but for the smelting operation, whenever it will go through, that also can generate arsenic pollution, right? But as I have told you that in case of arsenic, the major source is obviously natural sources. Now, if you go by the arsenic speciation in water, that arsenic, how it presents in water, arsenic mainly present, arsenic can present in both like organic and inorganic form, but mainly it is predominantly or inorganic form. And arsenic in water can present mainly in arsenic 3, arsenic 5 plus ion. Okay, so you know already how these metals forms ion. They will leave the outermost shell's electron, and then they can form this sort of ions. Now arsenic 3 plus and arsenic 5 plus, these two is very common for arsenic, and both of them are present in the water depending on some environmental condition, but more or less they present in 50-50 manner. Okay, you can assume that, although that is not correct always, but it present in such a scenario like arsenic 5 plus and arsenic 3 plus, but it will not present as arsenic 3 plus. Arsenic, where its oxidation state will be 3, it will be present like that, but it is not as arsenic 3 plus only. It can present in any of these 4 form. Out all of these 4 form, in all of these 4 form, arsenic is in 3 plus form. And arsenic 5 also can present in all these 4 forms, where also arsenic is in 5 plus form. Now, why we are going into that? Because you know that arsenic 3 plus and arsenic 5 plus, how much arsenic 3 will be present, how much arsenic 5 will be present, what will be the exact form, that will mainly depend on the environmental condition, that is pH and the redox potential. Now, why this is important in discussing arsenic 3 plus and arsenic 5 plus? Because any time whenever you will look for the normal natural pH, if you denote this shaded portion as the natural pH of water, then in the natural pH you can see arsenic 3 majorly present as H3ASO3, right? Sorry. Arsenic 3 is, yes, arsenic 3 is majorly present like H2ASO3 minus, H3ASO3 ions. Now, if you see in case of arsenic 5 plus also, what you will see, there is 2 sort of ions which is majorly present in this region. Now, whenever you want to remove arsenic from the water, what you have to do? As you can see, at neutral pH under oxidizing condition, arsenic will be present in these 2 form, and in reducing condition it will be present in H3ASO3 form. Now, whenever you have to remove the arsenic, what you have to do? You at first have to do is that you have to oxidize arsenic 3 plus to arsenic 5 plus. Why you have to do that? Because you know arsenic 3 plus is presenting as no charges associated with that. So to removal of these particles will be difficult rather than removing these sort of particles, right? So arsenic 3 plus must be oxidized to this sort of form so that ultimately we can remove them from the water. Hence, if you go for any arsenic removal technology, the first step will be oxidizing them, then to remove them from the water, because then coagulation and their final removal will be very much easier. Floc formation and their removal will be much more easier. Also, we have to keep in mind that arsenic 3 plus is more toxic than arsenic 5 plus. So arsenic present in the water, but obviously arsenic 3 plus is more toxic than arsenic 5 plus for the mammals specifically. That means if arsenic 3 plus is present, you are first converting it to arsenic 5 and then you are removing it. Arsenic 3 plus is almost 60 times more harmful than arsenic 5 plus for the mammals. Okay. Now, if you consider the toxicity of arsenic, even at its allowable level, what is the allowable level? We know that right now the allowable level is 10 microgram per liter. If you consider the other waterborne carcinogens, what is carcinogens? Those which create problem of cancer, generating cancer. If you compare with the other carcinogens, you will see even at the MCL or at the maximum allowable limit, even at that condition also, the cancer risk of arsenic is this much. That is 1000% per 1 lakh of people. But for the others, the risk is nominal. You can see in comparison to arsenic, their risk is nominal. So when arsenic is there, if you compare the other carcinogens cancer, other carcinogens means waterborne carcinogens. If you compare the risk of cancer, arsenic's risk of cancer is much higher, as you can see from this graph. This graph is prepared by us from a very reputed journal. From the journal we have collected the data and we have plotted it, and you can see this result. This is visually alarming how arsenic is problematic. Even at the MCL, I am saying this regularly, not at 50, not at 20, not at 30, even at 10 microgram per liter, if you are drinking the arsenic, this much effect will be there. This much risk of cancer will be there. Now, what are the health effects of arsenic? If you see, human body can be exposed to arsenic in two conditions. One, you are exposed to arsenic in a very high concentrated arsenic for a very shorter period of time, or it can be for a regular interval for a longer period of time. You are poisoned with arsenic. Maybe you are knowingly or unknowingly taking that. So we classify them mainly two period of time. That is, one is long term time or long period of time, which is also known as chronic poisoning, where you are getting the arsenic contaminated drinking water for a longer period of time. It should be more than 365 days. At that point of time only we will consider that this is a longer period of time. Then we consider short period of time, where exposure period is less than 15 days. And then there is medium period of time, where obviously the exposure is within 15 to 365 days. Now what will happen if you are drinking the arsenic contaminated water for a very longer period of time? What will happen? There will be several issues. There will be several sort of disease, several form of disease. There will be skin lesions, there will be gastrointestinal problem, cardiovascular problem, neurological problem, and obviously malignancy or cancer will be there. So you can see these are the organs which are affected by arsenic. You can see almost all the organs of human body is actually getting affected by the arsenic, right? So arsenic effect will be much more if the receptor is having certain sort of medical conditions already. That risk also will be elevated, right? So effect in the skin will be several types of disease, or several types of skin disease can be there, like melanosis, then leukomelanosis, dorsal keratosis, gangrene, cancer, all this sort of disease can be there. Then the effect, it will affect the respiratory system, also nervous system it can affect. So you can see these are some photographs which is even taken by us. Actually, I have been involved in a arsenic remedial or removal technologies. I have closely worked with that, and we have formed one team where we are having the social scientist also, because that is very important for placement of a technology, for using a technology in a better way. We are having the social scientist also, mainly people from the background of environmental economics and all these things. They have done the survey and they have found these photographs in your locality also, in Baruipur area also. Okay. Now, this is the district wise case in West Bengal. I am morely focusing on West Bengal. Bangladesh is also another area where so much case of arsenic poisoning you will see. Okay. In case of West Bengal, obviously the majorly affected two districts, if you consider, is North Chobbish Pargana and South Chobbish Pargana. Now, if you see number of malignant cancer is there, number of malignancy, if you consider, North Chobbish Pargana is higher than South Chobbish Pargana, but it is not less, because in South Chobbish Pargana, what is happening, a large area is contaminated with a arsenic contamination even of 200 to 300 microgram per liter. One school we have visited, there the arsenic concentration is 800 microgram per liter. And what is the MCL? MCL is only 10 microgram per liter. I have also told you that even at 10 microgram per liter, what is the risk? I have shown you. And if you're drinking this quality of water, you can imagine the situation. You can imagine what is the situation, or in what situation they are living, because sometimes they are forced to drink that groundwater, right? In North Chobbish Pargana, in some areas, even you will find in the Barasat and all these areas, you will find a regular concentration of 800 to 1000, like this. In some of the school or in some of the village also you will find a very, very high concentration, like 1500, in this range also. So that is very, very alarming situation. Okay. And you can see the other areas also. Okay. You can see Kolkata is little bit affected, Bardwan, Malda, Murshidabad is also one of the affected area. Okay. Now we are showing you the arsenic contamination scenario throughout the world. So I have plotted here the arsenic affected aquifers. So what we have done, we have got the information from the research paper, from the scientists, that where the arsenic contaminated aquifers are there, and we have plotted them. And you can see all the red areas are basically arsenic contaminated aquifers. Okay. And all these dots are basically arsenic related mining operation, like any sort of copper smelting operation is going on, where copper extraction and all these things is there. These things are there. These areas also water can be also contaminated due to anthropogenic activity. And these are the aquifers which is already containing the arsenic. As you can see, here is our area, that is Bengal Delta, which is also known as GMB plain, right? So it is almost polluting some areas of the Uttar Pradesh, and then majorly of the West Bengal and the Bangladesh, this portion. Okay. So I have already shown you the India's case also, but here I have also plotted in a Indian map, Indian context. You can see this is the one area in the Himachal, Chandigarh. In this area, you will find a little bit amount of arsenic concentration. Then this area, and then majorly, although you will find in the UP little bit, Bihar little bit, here little bit you will find, but the major area is this portion, West Bengal's this side. Okay. In GMB plain, which is majorly affected, and where the pupils are chronically affected due to the arsenic pollution, and you will sometimes get the concentration around 4000 microgram per liter also. So you can think of what is the scenario there, right? So this is the arsenic contamination effect. Now if you plot in West Bengal, you will see the reddish one is the more polluted in arsenic, where we have plotted arsenic, where the arsenic concentration is more than 50 microgram per liter. Then this yellow and reddish one, where 10 to 50 is there, and then green is where arsenic concentration is less than 3 microgram per liter, and then there is yellow and green, which is 3 to 10. So majorly this portion majorly, which is basically this, you can see the North Chobbish Pargana, South Chobbish Pargana, Malda, Murshidabad, this portion, and some part of the Bardhaman and Nadia also, right? This portion are majorly polluted. So in total 88,000 square kilometer of West Bengal's area, we have find out that if you consider arsenic contaminated area, if any area is more than 10 microgram, if in any area drinking water concentration is more than 10 microgram per liter, and if you calculate that area, then you will find out that nearly 38,861 kilometer square area is contaminated with arsenic pollution. Okay. Now, if you go for the arsenic treatment units, there are several treatment units. It is not like only in this year or in this decade we are looking for arsenic treatment option. Arsenic treatment option having a great history. We are trying our best. All the scientists are trying their best, and they are developing certain kind of technology. But very few of them are right now working. Okay. So whenever you are going for arsenic contamination or removal of arsenic contamination from the groundwater, you have to, in any of the treatment technology, first operation will be oxidation. Then you can remove them. First operation will be oxidation, because you don't know whether some of them will be in the arsenic 3+ form or whether some of them will be in the arsenic 5+ form, because ultimately before removal you have to convert them to arsenic 5+ form. Because although arsenic's state will be 3+, but arsenic will present as a neutral ion in the water when it will be neutral pH, that means in 6 to 8.5 if you consider. But arsenic 3+, if you oxidize them to arsenic 5+, they will be present as a anion, combined ion as a anion. Okay? So you can remove them easily. So that's why first operation in any of the technology you are using, there should be any oxidation operation. Now, if you go for the arsenic removal technology, there are oxidation operation, there are coagulation flocculation operation, there are adsorption operation, there are biosorption operation, ion exchange operation, and membrane process operation. There are some point of use technologies also. What is point of use technology? I will come to that later. Then there is electrocoagulation process also. I have mainly worked with the electrocoagulation process, so I will discuss a little bit more of that process, and the other process I will just go by. Okay. So if you go for the oxidation, obviously you have to oxidize arsenic 3+ to arsenic 5+, as it is a prerequisite. But normal air can't be able to do very efficiently this oxidation. Okay, so the efficiency of normal air oxidizing these things is very poor. Hence you can use some sort of chemical agent like ferret, manganese oxide, ferret. Look at this, it is not like Fe2+ or Fe3+, it is Fe6+, right? Then other ions also you can use. But normally we don't go for only chemical oxidation, because that is not very effective one. And also the huge amount of the sludge you will generate from this process, you have to dispose that sludge in an environmental friendly manner. Why I am saying environmental friendly manner? Because see, whenever any treatment is going on, any treatment, be it is in the water treatment, be it is in the wastewater treatment, or whether it is simple air treatment you are doing, remember one thing first: treatment can't assure you the goal of the sustainable development. Why? Because if you are doing any sort of treatment, you will generate some sort of byproduct. See, whenever you will remove the arsenic from the water, you are removing by converting them to some compound. So that compound, when you will dispose, that is basically a sludge, that can be again source of arsenic contamination, right? So you have to dispose this sludge or this byproduct which is generated in a very environmental sound manner, so that it is not again will not pollute the water bodies. If it is again polluting the water bodies, what will happen? Your entire concept of treating the arsenic or removing the arsenic is basically becomes null and void. Basically you are just wasting some money, some time, nothing else, right? So we have to also keep these things in mind. I will show you some of the technologies which right now is not working, which is used by the people of the West Bengal or the people of the locality by for some other uses. So you can see why this is failing, because the social development of that problem is not proper. So you have to dispose, you have to think about the sludge generation also, how we will think about the sludge, how we will dispose this sludge. So there is the problem with only oxidation. So that's why we will not go for obviously normal oxidation, right? Then there is microbial oxidation that can also happen. Several microbial population is there, several bacteria is there which can actually oxidize arsenic 3 plus to arsenic 5 plus, and ultimately is out of all this microbial population, obviously we can't consider every microbial population. Why? Because if we are removing arsenic, that is okay, but in this process if some bacteria is present and if they are pathogenic, then also we can't consider that water as a drinkable. So obviously you have to consider the pathogenicity of the microbial population also. Okay, these are the some scientific name of some bacteria which can oxidize Fe2 plus to Fe3 plus, and which then will oxidize the arsenic 3 plus to arsenic 5 plus. So like this, basically they will trap the oxygen and they will oxidize. Okay, now if you go for coagulation and flocculation, then what you have to do? You have to, at first, coagulation is effective once you have converted all the arsenic 3 plus to arsenic 5 plus. Why this is needed? Because as already I have told you, so arsenic 5 plus will present in the water as some anions, some combined anions, and arsenic 3 plus will be present in the neutral form. So obviously this charge you have to neutralize, and once it will be neutralized, it will agglomerate, like in normal water treatment also happening. If you are using or if you are adding coagulant, what is happening? The coagulant will neutralize the charges of the colloids and ultimately they will agglomerate. So same thing will happen with the coagulation and flocculation, but before that you have to oxidize them. Okay. Arsenic also can be co-precipitated with the flux, and ultimately you will get the flux. You have to collect the flux and you will get the water which is free from the arsenic, right? You can use lime as the neutralizing element, but for using lime, lime is effective when the pH of the water is 11 to 12. Now this is very alkaline range, so again you have to bring it down to 7 to 8, right? So that is also very difficult to play with the pH, because in normal neutral water's pH is normally 7, near about 7, 6.5 to 7.8, like this. Normally you will get, you can get up to 8 also, right? But to bring it to 11 to 12 is very much difficult. You have to add some sort of base or some sort of things. After that, whenever you are going again, you have to come down to 7, near about 7 or 7 to 8, because 11 to 12, that pH water having that pH, you can't drink that, because that is hazardous, right? That is toxic for the humans also. So you have to again bring it down. So that will be again problematic. So lime you can't use. Then you can go for aluminum based coagulants also, but the problem will be that for the arsenate removal, the optimum pH is 6 to 8, which we know. Hello. Okay. So aluminum chloride, which will be able to decrease around 300 microgram per liter of arsenic 5 plus to below 10 microgram per limit, below 10 microgram per liter. That means this method can bring 300 microgram per liter to below the permissible limit, right? Near 10 to 50 it can bring. So many technology you will find can bring the arsenic level less than 50, but very few of them you will find that they will be able to bring the arsenic level less than 10. Okay, whenever you are considering the less than 10 level, the technologies are limited. Then there is iron based coagulant also used. Ultimately you can go for adsorption also. There are so many adsorbent also there, where also they can also remove the arsenic from the water. But the main problem, what will be there with the adsorbent? Once its life or once it will be unserviceable, you have to either regenerate or either you have to replace this one, right? This adsorbent. So that will again can create the problem. Then there is some other technologies like ZVI, zero valent iron, and also red mud. Red mud is also there, which can also oxidize, but these methods are relatively slow process. Okay, zero valent iron, if you are uh, making it in situ, then it is okay. But this red mud, this sort of method, they are very means the speed of the reaction is very less, so removal efficiency is also, you will see the removal efficiency will good, but you have to allow for a longer period of time, which will not serve the purpose for supplying drinking water to a village community, right? Activated alumina can be there, and we are in our West Bengal also, we are having another group of researchers, those who have worked with the activated alumina part also. And activated alumina also can remove the arsenic from the water, but again the regeneration of the activated alumina will be a much difficult one, because you will get the spent media. What happens in this sort of medium, the water, contaminated water will pass through, and ultimately the product or the fresh water, drinkable water, you will get from the bottom, but this activated alumina will get contaminated, contaminated, as the arsenic will bond with all these things, right? So what will happen after the lifetime of a after the period of operation of this activated alumina, you have to regenerate it, and at that time you will get a spent media, which will be again problematic. So you have to look at these things also. Only you are developing, if you are developing a technology, that will not be enough. You have to go for the, you have to think for the other aspects also, right? Then granular activated carbon also can be there, or biosorption can be there. Biosorption is also another option to remove the arsenic, but these are, again I am telling you that these are not very much faster option. However, ion exchange, cation exchange, these are faster option. It can remove the arsenite and arsenate also, that means arsenic 3+ and arsenic 5+ also, up to 98%. Okay, so up to 98%, these things are also can be removable. These things also can remove these things, but what will happen, the cost here will be very high, because you have to use the resin, and resin will serve for a very shorter period of time, and the cost will be very high. Anion exchange and cation exchange, both the things you can employ, and ultimately the cost will be a little bit higher on the side. Okay, so you can employ the membrane filtration process also, but membrane filtration process will not be very effective in removing other than the reverse osmosis process. But what will be the problem in the reverse osmosis process? Okay, in the reverse osmosis process, what you will get, that the waste water generated from the reverse osmosis process, or the byproduct water which is generated from the reverse osmosis process, is a huge one. So the water wastage in the reverse osmosis process is also very large, and you have to again either throw that water, or because you are when in the reverse osmosis process, what is happening, arsenic on its own form actually getting removed. So it is again can be the source of arsenic. If you throw that water in nearby, and if that water again reaches your pond or your surface water bodies, then it can contaminate the surface water bodies. Remember, this arsenic contamination is predominant in the groundwater. That means the water you will get from the well, or the water you are taking by boring these things, there only this arsenic problem can be there in the arsenic contaminated area. But in the surface water, normally this problem is not there. But if you employ reverse osmosis or any other thing, any technologies, whatever be the technologies, but if you throw that water, or throw that byproduct which is generated without treatment, if you are sending that or throwing that in nearby land or nearby water bodies, that can again be contaminated, or can be a new source of arsenic. Okay, as I have told you that it can remove the 97% of this one. but the huge amount of reject water will generate. Okay. Now we will talk about the some point of use technology. Point of use means where you need the water, there you are using the technology. Other technologies which we have discussed, basically you are applying for the community. Like for a village, you are treating the water at a particular place and then you are distributing that water, right? But point of technology are the some sort of filter which you are using in your household and you are getting the arsenic free water. But what will be the problem in this sort of technology? Again, that byproduct, the sludge or the byproduct or the spent liquid, whatever you will generate, the people don't understand, the layman people, they don't understand what will be the problem in throwing that contaminated water in a drain or in a river or in your nearby land. They don't know. So we have also come across several technology, those which are point of use technology. They are the normal layman people using this technology in their household and they are throwing that arsenic contaminated waste in the nearby, right? So that is also will not be effective in this way. So for that reason, you have to go for the community treatment, but you have to also use a model where you can regularly supply this water to the villagers. If you just install that technology in the locality and you are saying, okay, my job is done, I am not able to operate these things, the operation will be on the villagers. Okay, let me just take one minute. Has it? কত জন দিয়েছে? ঠিক আছে স্যার, একটু পরে দেখি, আমি একটা একটা মানে ডিসকাশনে রয়েছি, ঠিক আছে, আমি একটা প্রেজেন্টেশন করছি। So that's why this sort of technology is also very difficult. Okay, and this sort of technology even installed in West Bengal, Bangladesh, all over the world also, right? You can see RKM filter is there, CMRI filter is there, all these filters is basically household filter. So then there is so many others, so many point of use technology. You can see we have not only completed the list here, the other point of technology also is here, some point of use technology, but they are problematic in this way also. They are not actually able to remove a highly contaminated arsenic water. Okay, they can remove the arsenic contamination of 100, they can bring to 40, 30 like this, but they can't remove a huge quantity of arsenic. These methods are not able to treat that. So here comes the process of electrocoagulation, where we have worked along with the one of the topmost university of the world, that is University of California, Berkeley of USA, and we have formed a team and we have worked in this technology called electrocoagulation. The patented name of this technology is ECAR, electrochemical arsenic remediation. Okay, where we are doing what? In the anode, from the MS plate or any sort of steel plate we are using, there we are generating some sort of cations first, and in the cathode you can see the water is getting converted to OH minus. Okay, now these cations will be helpful in oxidizing arsenic 3+ to arsenic 5+, and then in situ on that place some adsorbent will generate which will absorb those arsenic 5+ ions. Okay, arsenic 5+ forms of water ions. Okay, now electrocoagulation previously also used by several researchers, but in ECAR specifically what we have done, that I will come across, that is a success story, so that I want to share. So you can see before this going into the ECAR, what is the advantage of ECAR? I will discuss a few more points of why this arsenic remediation problem, arsenic contamination problem is very hard to solve. It is known to us from like say 30 years, 40 years back also, or 20 years, 30 years back also, not 30, 40 years, 20-30 years back also. But why it is very difficult to solve this problem? Because if you install a facility in a village, okay, and if you told them, or if you say that, okay, my responsibility is over, right now you have to operate these things, then there will be a chance that after a few months it will be in not operating condition, because it is not possible for a layman or for a villager to operate this sort of technology. Also the field performance, because some technology we assess in the laboratory is performing well, but when you are placing that in the field, it is not capable of removing the arsenic up to 10 ppb level. Then the disposal of the sludge or any byproduct which is generated, that is also one important problem. And then the low ability or willingness to pay for the water. We know, we till now we consider water should be free, but if you make water free, you know there is the behavioral change of the people will consider it as a valueless. Okay, so even if you are, say, from the government, you are giving the people 100 rupees for water, but they should pay 10 to 15 paise for per liter also, because that will develop a behavioral change among them. They will understand the value of these things. Otherwise the people will not value your work, will not be able to understand what is going through in treating this arsenic. Okay, so also very low safe limit of WHO is also another problematic thing, because you have to go up to that level, right? And also arsenic 3, which is very harder to remove, so ultimately you have to convert and then remove. So all these things are the problem. And then there is some competing ions in the groundwater is also there, so which can also create problem for arsenic removal. Okay, Sandeepan sir, how much time we are having?
Sir, you can continue.
Okay.
No problem, sir.
Okay, so that also will be a problematic thing. So ultimately, considering all these points, you have to develop certain technologies so that they will be so they can address all of these points, right? Only at that point of time, the social placement of a technology which is developed by the hard work of the scientists, by the researchers, can actually solve the problem. So ultimately you have to make a group of the scientists, of the researchers, of the social scientists, of the people who will ultimately operate. You need those people also. Okay, so ultimately if you combine them, then only you can solve this sort of problem. Otherwise we are unable to solve this problem by only doing the research, right? Okay, so even I have told you that we have formed a team, and one of the faculty, a member of Vijayagad Raj College, that is Dr. Ovijit Das. He have done his PhD from Jadavpur University also. He is from the environmental economics background. He have done a detailed survey of all the failed technologies, and you can see all these technologies in the background. All the pictures are there. They are actually installed by the government, paying some hefty amount, some huge amount, but ultimately right now they are not working. How people are using them? People are using them for this purpose. Is it for this sort of purpose? No. Why it is they are using like this? Because these are not working. So within 6 months all this technology is failed. Okay, very few, only 10% of the technology is running till now. So he have actually that is the outcome of his thesis also, and he have actually surveyed a large group of people there. Okay, so for a technology to be sustainable, the technology must be effective, must be robust, and must be affordable. Also it have to address the problem of environmentally disposal of the sludge also, right? So this is the team we have formed. You can see there is the science and mechanism. Some people will study the mechanism, what is going behind. I have not went for a very detailed discussion in the technical part, but there is a very complicated process of changing of the ions, Fenton reaction, all these things are going on, which is studied by some of the researchers. Their main work is to study the fundamental science and mechanism. Dr. Kees Van Januchen of University of California, Berkeley, at that time, he's the researcher. Right now, he's the faculty of University of Utrecht. Then Lei Li of Environmental Engineering of Tongji University of China, and Jack Pena. They are studying this background mainly. So we have formed this team. Then there is health and economic impact is studied by some people, like you can see all the names. Professor Abhijit Das and Dr. Jayashree Roy from Jadavpur University is also there in this team. Then doctors are also involved in these teams, like Kunal Mojumdar of KPC College. And then there is some NGOs person like Toimur Khan, because they will ultimately make sure that the water is getting the peoples are getting the access of this water, right? Or they will deliver this water to the peoples also. Then there is for the business model, we have what we have done. We have formed a group of the scientists, the local peoples, and some company also. Initially, we have actually a partner. In case of Baruipur, we have installed one technology. We have partnered with one of the company also, and then there we have built up one treatment unit also. So initially, our business model partnership building is carried out by the people of the University of California, Berkeley also. And in the field trials of the technology and certain modifications of the technology is mainly carried out by us from Jadavpur University Department of Civil Engineering. So Jadavpur University involved in two ways. One is the prototype, because ultimately in the lab which we have developed, we are basically transporting them, or we are basically making the larger version of that, and it should operate in the field, and we are providing the necessary technical support for that. And our Jadavpur University environmental economics department also involved in this. So we have formed this sort of team. Only after that we have basically installed one of this sort of technology in one of the school of Baruipur to make a model. Then that model can be replicated, right? So I have although explained a little bit about the remediation, how it will happen. Specifically, Fe2 plus will be produced from the anode, and it will become Fe4 plus for a very few parts of the time. And when it will come back to Fe3 plus stage, it will basically oxidize the arsenic, and ultimately it will get settled in the bottom because it will be absorbed by the Fe3 oxides complex. Okay. Now these are the result of our ICAR when we have started with at first a 2-liter beaker in the University of California, Berkeley. Then they have done a 25-liter prototype. Then in Jadavpur they have gone for 100-liter prototyping. Then we have done in the Jadavpur 600-liter prototyping. Then we have right now increased the capacity in a single batch up to 5,000 liters. So this is a ongoing process of increasing the capacity, because you have to study all the effects also, because whenever you are changing the depth, changing the current density, whenever you will do these things, obviously there will be certain kind of changes. So this to come up to this level of installing a long batch sort of technology in a school in Baruipur, we have been researching for a very longer period of time. Okay, so you can see even when we have in the Baruipur at first, before installation, what we are doing, we are testing the water quality of every school. Now the question is why we have chosen a school, because in that area also disseminate the information that that area's water is polluted. That is also very important, and that's why we have chosen a school, because the school children will basically is the most effective medium of conveying this sort of information. So we have also carried out some education and outreach program in 2009, since 2009 I should say. And then at first what we have done in Murshidabad, we have installed a 600-liter capacity. Then in the Baruipur we have installed a 2,500-liter per batch capacity arsenic treatment plant. So this is the pictures from the Murshidabad area, and you can see the results in the school we have chosen. In that school, this is the field trial. In the field, suppose if you if you are getting 302 microgram per liter of arsenic in your water, in your inlet water, we are able to reduce that below 10, right? Below 10 on a consistent basis. And we have not only checked for 302, this is the field trial, this is the natural water which we have tested, but in the laboratory we have make water which contains arsenic in the level of very high dose like 4000 microgram per liter or 5000, 6000, and we can bring that to even to less than 10 microgram per liter, right? So now how we have scale up these things. This is one of the model in the Andhra Pradesh, where basically what is happening, you are having a card or you are having a can where you are taking the water, and for that 5 liters can, suppose you are paying 50 paise or 60 paise. For arsenic treatment maybe it is 2 rupees or 3 rupees, even considering the profit of the company. And even selling 10 liters or 50 liters, 10 liters or 5 liters for 3 rupees, that can be also affordable by making all the cost, means all the cost for running that plant, that can be done. So we have studied this effect also. And in Baruipur we have installed our plant in Dhopdhopi High School. Dhopdhopi High School in Baruipur, we have installed one plant where the school children, school authority, the teacher, they all are getting the water free of cost. They all are getting the water free of cost, but the company, those who are running, they are selling the excess water to the Baruipur's community or Baruipur's normal villagers in a very affordable rate of 3 rupees for 5 liter, like this. Okay, or maybe 10 liter, I do not currently, maybe 3 rupees for 5 liter or something like that, they are selling their water. Okay, yes, in this ratio 3 rupees per 5 liter. And this will be even profitable even after after arranging for the consumables and meeting the day-to-day need. Some people will be associated with the plant after making their salary also. We are actually happy to sell this water with these low prices. So you can see what is the cost here. Cost here is very less. Only you need some iron plate and you need the cost of the electricity. Obviously you need the other parts of the plant, but mainly here consumables is that you're not adding extra anything agent. Okay, you can after that ECAR operation, you can again go for your coagulation or any other high end of treatment, but that is not needed. Only arsenic, even this only iron plates can do, or iron plates, your through iron plates is only needed, or that is the only consumables you need. And the electricity, you are basically sending the electricity through this plate, and you are basically removing the arsenic. So here our rust generation is our target, because you know more electricity will pass through this plate, more ions will generate, and more arsenic will get converted. So much rust you will generate, that much if you are generating the rust in a much higher ratio, obviously you are also treating the arsenic in a very effective manner. Okay, so as you can see, extremely effective and robust in treating arsenic of less than 10 ppb, arsenic 3 or arsenic 5, anything. The minimum supply chain produces very little waste. The waste generated from here is very little. If you consider a person's even throughout the years drinking of water, they will not generate more than 300, more than 100 gram even of waste. And that waste also, we have worked with that waste. We have taken that waste and mixing with the concrete, as concrete is a very alkaline medium of pH nearly 13.5. So arsenic is not coming out of that concrete medium. So we have also tested that sludge. That sludge itself is not will not come out of the sludge as arsenic ion, or arsenic ion will not come out of this sludge as arsenic ion. But even if you want to be very sure, much more sure, then you can make concrete with this sludge, and ultimately it will not come out of that. So it will not create the problem again. Okay, so these are our teams. You can see this is in the Dhopdhopi, when first 600 liter also, which is made in Jadavpur, At first it is installed in Dhabdopi, then it is bring back to Jadavpur, and then in Dhabdopi High School, 2500 liter per tank per batch capacity is installed, right? And these are the result. You can see it is so low than 10 also. So it will be very effective in treating the field water also. Okay. So in long term, what we want that this sort of technology will be helpful for the community. It can solve the necessity of the basic necessity of the people. It can serve the basic minimum, that is safe drinking water, to the people, which is very much needed, because it is not their fault. It is not the fault of the people, those who lives in the nearby area, right? It is the geological condition which forced them to drink that water. So obviously it is a difficult scenario. We have to give them the safe drinking water sources. Okay. So arsenic disposal also, there can be several methods, like disposal to the landfill, which is an unengineered method. Mixing with the cow dung and disposal, that is also not very engineered method. Then disposal in the water bodies, that is also not very acceptable. Disposal in the soil, it is not also very acceptable, because you can see all of this can contaminate the, or can be the further sources. So ultimately we are going for, if you want to go, you can go for the solidification or stabilization, which is basically mixing with the concrete. Okay. And of the concrete also, we have tested the so many properties like strength, leachability, UPV, carbonation test, all these things we have done, and it is very much okay to say this, that this structure also will perform well even in the aggravated environmental condition. Okay. Although we do not recommend the use of this sort of concrete in a very high strength structure, but at least in the nearby of the park, you can make some sort of bench and all these things. Then you are using that sludge also. You don't have to transport that sludge to somewhere else, and you have to just throw them away. Okay. So that's all from my side for today. If you are having any question, you can ask. Otherwise, we are done for today. Thank you all. Yes.
Thank you, Dr. Abhishek Roy, for sharing your ideas and knowledge on arsenic contaminations of groundwater in GMB plan and the mitigation technologies. I hope that this presentation should enlarge the knowledge of the participant, and so I now request all the participants, if anybody have any questions on today's topic, you can please make a consultation with sir. So participant, do you have any questions? Please unmute yourself and ask the question to sir. Anybody have any questions? Actually, sir, I have one question to you, sir. So can I ask you now? Sir, actually, I know what is the significance of arsenic and sulfur correlations in the in soil and plants. So can you please tell me about the portions?
No,
That is,
okay. Actually, yeah. Actually, my part is more on the removal of this, and I then arsenic and sulfur's correlation I have to see and get back to you, because I have not worked on that aspect majorly, right? So I can see those things and I can get back to you. Okay, because that is actually ideally not my part. That's why I have not studied these things. Okay.
Okay, sir. Okay, sir. No problem, sir. Thank you. Participant, anybody have any questions? I hope that there is no questions for you. So once again, sir, thank you once again, sir, and it enough issues for you, sir? Can it is it visible to you, sir?
Which
Is it
one?
visible?
No, yeah, yeah, yeah. Hello. Yes, it is visible.
It is visible, sir.
Yes, yes, yes.
Okay, sir. So later we will send it to you, sir, in this your email ID,
Hmm,
sir.
hmm, hmm, hmm. Okay, okay, okay.
Okay. Okay, sir. Once again, thank you very much, sir.
Hmm.
Thank you, Principal Ma'am, for your kind cooperations with us, and thank you all the faculty members of Civil Engineering Department and the member of the Eco Club of Greater Kolkata College of Engineering and Management. So here I am concluding the sessions. I hope all of you should stay safe and healthy. Okay. Okay, sir. Thank you, sir.
Yeah. Okay, 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 okay.
Okay, sir. Thank you, sir.
Hmm.
Sir, can I ask you something? Hello,
Yeah,
sir.
sure.
Sir, my phone was changed. I accidentally got exited from the official WhatsApp group of our Eco Club. Can you join me in again, sir?
Official WhatsApp group where
We
you
will,
are.
let me answer this. We will convey this message to the convener of Eco Conference again.
Sir, I couldn't hear you.
What I'm saying, yeah, this message will be conveyed to the convener of Eco Club to include.
Sir, your voice is getting interrupted.
Actually, sir, I want to tell you that is the please, who is the convener of Eco Hub. You please convey your message to the convener. Okay, he will guide you about your problem and added you into the Eco Club group. Okay, understood?
To the coordinator, sir.
Yeah, that is convener. I hope that is convener of your Eco Club. That is Dr. Onubroto Mondol, sir. Okay. So you please contact with Dr. Onubroto Mondol, sir. He will guide you about your problem and I hope you will solve you the problem. Okay.
Okay, sir. Sir, the Google form is not
You have the
opening.
problem that is you are. I think the Google form is open because already I have received the responses from the participant.
No, sir, it's still not opening. Sir, then what should I do, sir? The form is not opening, sir.
Okay, so just wait.
Okay, sir.
Please check it.
Okay, sir.
Okay, so I am concluding the sessions. Hopefully you will already stay safe. All of you should stay safe and healthy. So thank you all. Goodbye.